Hi everyone. Today I am going to discuss about motion in a plane chapter. Before that, those who are watching my videos first time, do subscribe my channel and do like and do share the videos with your friends. Dear students, in previous class I discussed about the speed, velocity, okay, and scalar quantity, vector quantity. Here today I am going to discuss about acceleration today. Acceleration means it is also one of the physical quantity in which we are observed in motion of a body. Here the definition acceleration means the rate of change of velocity with respect to time. It is the rate of change of velocity with respect to time. Okay, and it is a vector quantity. It is a vector quantity. Why it is a vector quantity? Because it has both magnitude and direction. That's why it is a vector quantity. And SI unit is meter per second square. Here we have the formula acceleration equal to velocity by time. Okay, velocity by time. Velocity means displacement. Okay, displacement by time. Okay, and again here time is there. Okay, that becomes distance. Okay, means in terms of length means SI unit is meter. Okay, meter, this comes to the here, time comes to here, that's why this is a second square. Okay, that becomes meter per second square. Okay, meter per second square is the SI unit of acceleration. And here in acceleration again we can able to observe the two type of accelerations, that is instantaneous acceleration. It means acceleration at instant of time. For 1 second how much the acceleration, and for 5 seconds what is the acceleration value. Like that we are observing the intervals of acceleration are known as the instantaneous acceleration. Next one is the average acceleration. When we do the summation of all those instantaneous acceleration, we will get the average acceleration. Suppose if we have the five instantaneous acceleration values, we have to add all those five values and divide by 5, then it is the instantaneous, sorry, then it is the average acceleration. Okay, next we will discuss about the position time graphs. Okay, position time graphs. Here these are the graphs which indicates the particle motion, particle motion, and from where the motion is started and how the motion is started, that is observed by the graphs. Here position time graphs. Okay, in x axis we are taking the time interval, okay, time magnitude. In y axis we taken the distance position, okay, distance magnitude. Okay, here in the first graph, here we are observing that straight line, okay, from certain position, means we are not observing any movement in the position. That's why this graph is indicating that object is at rest. This indicates the object is at rest. Okay, object is having no motion with respect to time. And here in the second graph, from the origin point the straight line is like increasing order. Okay, that we are observing, this is the increasing order of a particle motion. Here for this graph we are naming it as a object moving with uniform velocity, object moving with uniform velocity. Okay, here like that we can easily observe the equal intervals of distance with respect to equal intervals of time. Okay, that's why we are calling it as a uniform velocity. Next one. Okay, here In this graph, the object motion or particle motion is in the form of increasing order that you are observing here. This is the increasing order from 0 to increasing order, higher values. Okay, such type of graphs are known as object moving with increasing velocity. Object moving with increasing velocity. And in this graph, the object is increasing for certain interval, and after that the time being the graph is decreasing. Okay, like that. It means the object moving with decreasing velocity. Okay, these are the graphs indicating the position time graphs. Okay, next one is here velocity time graph. Okay, here also in x-axis we taken the time interval, in y-axis we replace the position and we introduce the velocity. We are taking the velocity magnitudes here. Here also we are observing a straight line with certain position on the velocity line. Means the body is moving with a starts moving with certain initial velocity. ಅದಕ್ಕೇನಿದೆ initial velocity ಇದೆ, ಅಲ್ಲಿಂದ movement ಆಗ್ತಾ ಇದೆ. Such type graph is known as body moving with uniform velocity. The body having certain uniform velocity. Okay. Next, this is a increasing order. Here the body moving with uniform positive acceleration. Uniform positive acceleration. Okay. Here, okay, this is one velocity and this is one velocity. As you know that acceleration means velocity by time. That's why here we are using the word acceleration. The body moving with uniform positive acceleration. Next one is here the body also having certain initial velocity and moving in a higher order. Okay, this graph is known as body moving with certain initial velocity to positive acceleration. Here increasing order that we are observing in the graph. That's why it is a positive velocity. Next, here in this graph, the body having certain peak velocity, higher velocity. From that magnitude, the body goes on decreasing. Then after it reaches 0 from higher to lower. Okay. This graph is known as body moving with negative acceleration. When we observe a decreasing curve in a graph, that indicates negative acceleration. Okay. Next one, here increasing order curve is there. Okay, the body moving with increasing acceleration. Okay, and here the body moving with decreasing acceleration. Okay, these are the graphs which indicates the particle position in a particle motion in different aspects. Okay, okay, remaining concepts we will discuss in next class. Thank you.